All right. So, like we weren't doing Pythagorean theorem here. We were just using the Pythagorean triple. Here we were using Pythagorean theorem. Remember, leg squared plus leg squared equals hypotenuse squared. But that's because we have a right angle. On number 4, the question is that a right angle right there? Right? That's the question. So if you set up Pythagorean theorem and it works, then yes, then it's a right triangle. And in this case, if it worked, these three numbers being whole numbers make them a Pythagorean triple. Now, 8, 13, and 14 is not over on the wall. Not all Pythagorean triples are on the wall, but it would be kind of a good thing for a number like as simple as 8, 13, 14 to be on the wall. So the fact that it's probably not a right triangle. So let's see what happens here. We get 64 plus 169 when we square these guys, and we get 196 when we square 14. And when we add these two together, we end up with what 233, I think. So we have 233 on this side. That's obviously not equal to 196. So no, it's not a right triangle. Okay, it's acute. It's an acute triangle. Now, why is it an acute triangle? Well, this is where the hypotenuse is. At least it's hypotenuse squared, right? So that means it should have been 233 right here if it was going to be a right triangle, right? So that really means that 14 is too small. And what that does is, remember how we put our hands together and we said, okay, if we have a right angle right here, the distance between my fingertips is the hypotenuse. If that gets if the hypotenuse is too small, then it's acute. If the hypotenuse is too big, it opens up and becomes an obtuse triangle. All right. So that's the number that you need to focus on. Is 14 too small or is it too big? And you can see that it should have been bigger so that we would get 233, right? All right. Hope I made that clear. Number 5, because it's a 45, 45, 90 triangle, you have some relationships that I need you to memorize. The legs are equal to each other because the angles are equal to each other. So don't do any work. Just put a 6 right there. And then to get from the leg to the hypotenuse, you multiply by the square root of 2. So you put 6 square root of 2 for the hypotenuse. You're done. The 30, 60, 90 triangle is just like that. You need to try to memorize the rules. And the rule for the 30, 60, 90 triangle is the hypotenuse is twice as much. So you multiply by 2 and you get 10. And we did a proof of like why this works. There's another triangle over here that would be identical to this one, congruent to this one, that makes it an equilateral triangle. So when you drop this altitude down, it cuts this side that I'm not showing because it would run into this problem down here. It cuts it into half, right? Half of whatever the 3 sides are, and each side would be 10 long. So when you cut it in half, you get 5. Then if you use Pythagorean theorem, you get that this side over here is square root of 3 times bigger. So if you multiply by the square root of 3, you get 5 square root of 3 for the x side. Okay, so 5 square root of 3 there, and the y is 10 long. All right, number 7. This is where sine, cosine, tangent come into play. So I would definitely have down on my paper SOHCAHTOA. Okay, as soon as I start the test, I would write SOHCAHTOA or have it on my cheat sheet, right? And so what we need to identify is from the 35-degree angle. If 35 is my focus, then across from 35 is the opposite leg. Okay, this is the opposite leg. And the two sides that make up 35 degrees, one of them is the adjacent leg and the other one's the hypotenuse. So this is the hypotenuse because it's across from the right angle, right? So the hypotenuse is over here. So which one of these 3, sine, cosine, or tangent, has O for opposite leg and H for hypotenuse? Well, sine does, right? So you go sine of 35 is equal to the opposite leg over the hypotenuse. That's why it goes O, then H, because we're trying to say the opposite over the hypotenuse. And to solve this equation, we're going to multiply both sides by 10. And what happens on the right side, when you multiply both sides by 10, is these 10s divide out to 1. And we're just left with an x on the right side of the equation. And then on the other side, we got to go over to Desmos and we've got to do 10 times sine 35. And you've got to remember 10 sine 35 that, obviously I can't get a negative number, so I'm in the wrong mode. You got to switch over to degree mode, right? There it is right there. And so 5.7 is my answer on number 7, 5.7. Let me put that right up here, 5.7. Okay, let's go to the next one, number 8. Okay. Oh, I already set up cosine, right? Because I told you that, well, maybe I told you, I don't know if I did or not. This is the adjacent leg right here, right? This is the adjacent leg. And then this is the hypotenuse over here. We said that the hypotenuse and the adjacent leg make up the angle that you know, right? So I'm going to use cosine, and then we multiply both sides by 12. So x ends up being 12 times the cosine of 20. Very similar to how I multiplied the other one by 10. Because the 12 is in the denominator, we want to multiply both sides by 12, right? And we jump over to our Desmos, change this guy to a 12, change this guy to a cosine function. And what was our angle? 20 degrees or something like that? 20 degrees. So 11.3, if I have that right. Yeah, it was 20 degrees and it was a 12. Yep. So 11.3, I'm going to round to the tens place, 11.3. On this one here, I've got to find the x and the y. I would start with the tangent of 70. So the tangent of 70, because this is the opposite leg from the 70 degree angle. Remember, what makes the angle is the adjacent leg and the hypotenuse. So what's left over is the opposite leg, the one that's across from the 70 degree angle. So I've got tangent 70 is equal to x over 10, multiply both sides by 10, and I end up with 10 times the tangent of 70. Okay, so we jump over here, change this guy to tangent, and change this guy to a 70, and change the 12 to a 10, and I got 27.5. So x comes out to be 27.5. Once I have that, I could do Pythagorean theorem to find y, or I could set up the cosine of 70 is equal to 10 over y. Now, this one's a little trickier because the y being in the denominator, when you multiply both sides by y, you get y equals the cosine of 70, 10 over y times y. The y's divide out. They're gone. They divide to 1. So now we got 10 is equal to y times the cosine of 70. And then we said you divide both sides by the cosine of 70 to get the y by itself. Cosine 70 is just a number, and usually our number's in front of a variable. So I hope it doesn't mess you up that it's after. It doesn't even look like a number, right? But we're dividing by cosine 70, and you get 10 over the cosine of 70. Now compare this. This is what I'm going to type into Desmos with the way I started. Do you notice how like cosine of 70 over 1, where the y and the cosine of 70 are located, they've been switched. Now it's like y over 1 is equal to 10 over cosine 70. So what I was trying to tell people is this proportion here is equivalent to this proportion up here. You can switch the locations of these two and be done without doing all that algebra. So I'm going to type in 10 over cosine 70 in here. So 10 divided by cosine 70, and I end up with 29.2. So practice that on your Desmos. What did I just say? 29.2. So 29.2 for that one. All right, what do we got here? Ooh, we don't know the angle, right? We don't know the angle, but this is still the adjacent leg, and this is still the hypotenuse. So I'm going to set up a cosine. I'm going to say cosine of x is equal to the adjacent leg over the hypotenuse. And all along, we've been asking for the ratio by saying cosine of 70, tangent of 70. Cosine of 20. Hey, computer, tell me the ratio. But now I don't know the angle. So the computer isn't going to tell me the ratio. We're going to tell the computer the ratio. Here's our ratio. And we're going to ask it to tell us the angle. And the way you do that is you do the inverse cosine. The inverse cosine says, hey, tell me the angle. I have the ratio. Okay, the ratio of the adjacent to the hypotenuse in my triangle is 13 over 20. So I jump over here, and I've seen a couple people where their computer won't let them do Shift 6 to get up in the exponent. If your computer doesn't let you do that, you've got to open up this little menu right here, and look over here in the functions, and there's the inverse cosine right there. You can just click it. I don't really like doing all those little clicks. I would rather just type it. So if your computer allows you to type it, just put inverse cosine and then parentheses, and then you got to tell it the ratio, right? So my ratio was 13/20. So every time you go off the screen, it puts the cursor somewhere else. That's unfortunate. I wish I would have left it right there. So I got 49 point. Ooh, look at this. There's a 5 there, then an 8 and a 3. So it's over halfway to 0.5, right? To 5/10. Right now it's 58 thousandths over here. So that's, more than halfway to 5/10. And so I'm gonna round up 49.5. All right, so we come over here, we put down 49.5 degrees. Let's put some units on that thing. 49.5 degrees. I don't have units on anything else. I should have done that, like centimeters, meters, all that kind of jazz, except for number 11. 11 does have some units. It's supposed to be like a real world problem. An arborist walks away from the tree 100 feet. So where's my pen? Okay, there we go. 100 feet right down here, 100 feet. And she wants to know how tall the tree is. So we want to know this height right here, right? That's the opposite leg. The X is the opposite leg. The 100's the adjacent leg. Remember, adjacent makes the angle with the hypotenuse, right? So this is the adjacent. That's the hypotenuse. That's the opposite leg. So I'm going to do tangent of 20 degrees, and I'm going to set it equal to X over 100. And all we have to do is multiply both sides by 100, and these guys divide out. And so now I'm going to go 100 times the tangent of whatever it was. 100 tangent 20, I think. 36. Yeah, I want to make sure my numbers are right. 36.4 feet. Okay, so, geez, did I give you a line? Yeah, right down here. 36.4 feet. All right. Hey, thanks for watching my video. I hope I'm making this clear. If I'm not, call me over. I'll help you out.